In the last class, we learned how to use ENDL to write output on different lines. So if I write cout m, that's going to write the value of m, which is 5. If I write cout n next to it, it'll write the value of n next to 5, which is not good. So therefore, in between, we write cout ENDL. That will move the cursor to the next line of the screen before writing the value of n. That way, the output will have two numbers, one below the other, like this. That'll be a better display. Now, here's another example. So the same example can be now written this way. Int m equal to 5 and equal to 2. Both can be done in one line. Then cout m followed by ENDL with the arrow in between, another arrow and n. This means write the m first, then go to new line, then write n, all said in one line. You can write the program this way. That's how we normally write it. Here's another example. Float num1 equal to 2.78. Num2 is another number. Ans is another variable to store the answer. You declare all of them in one line. Then write ans equal to num1 times num2. Cout ans with the ENDL. The ENDL at the end is helpful to move the cursor to a new line after writing our output. That's because sometimes the system will write other things after your output. So you don't want those to get mixed up with your output. So put them on a new line by putting this ENDL at the end. You're moving everything to a new line. All right, two more people. All right, so right after writing the answer, I'm writing ENDL so that cursor will go to the next line before writing anything that system writes. Okay, so adding explanatory text, we can add explanation as to what the number displayed on the screen is as part of the output. So the output, if you just write the answer on the screen, without any explanation as to what it is, it may be confusing for a reader. There's a number displayed on the screen, and what is it? So we like to write some comment, some explanation as to what it is that the number is, the number being displayed. So to do that, all you have to do is write your text within quotes, within double quotes. Hold on, chariots. So, for example, float price equal to 25.0. So now I want to write this price on the screen. When I write this price on the screen, I want to be able to say current price is this, and I want to put $ in front of it too. So the only way to do that is to put that current price is and then $ all in double quotes after the arrow. So cout arrow, and then put this text in double quotes, and then another arrow. Everything has to be separated by arrow, every individual item. Price, and then arrow, ENDL. So if you write it this way, then the current price is $, all that will appear in front of the value of price. So this is how the output will be. Current price is $25 on the screen. So it's now nice and clear display that anybody can easily understand. It's the current price.
I have a question.
And the $, if you want the $, you have to include that within your double quotes. Now, suppose that I want a space after the $. Normally we don't do that, but let me just say I want a space. Then I have to include the space within the double quotes here. If I put that space right there, then there will be a space here in the output also. So everything you write within the double quotes will appear exactly the same way. So going on to the next, escape sequences. Escape sequences are sequence of two characters, backslash combined with another character. So any character you write with backslash within double quotes in your cout statement is called an escape sequence, and it is designed to improve the output. Basically, make the output better. For example, backslash n. If you write that within double quote in a cout statement, it means go to new line. So it's same as ENDL. There's no difference between ENDL and backslash n in the program. So let's see all of those escape sequences first. Backslash a. Now all of these have to be in double quotes when you use them. They only go with the cout statement, but they have to be in double quotes. So backslash a makes a alert signal. A stands for alert. It's a beep sound. Now you have seen when you use computer, if you do something that is not expected, the computer will make a beep sound. It's not the computer doing it by itself. The programmer made it happen. So you can make the computer make a beep sound when the user does something you don't want him to. Then backslash a in double quotes is what you use. Backslash b means go back one space. The cursor on the screen will be moved back one space. Let me show you an example of how you use that. Let's say I'm using the board now. So let's say you want to write a number. So I'm declaring a variable int m equal to 6, and then n equal to 7, and then I cout n, and then in this backslash b, if you want to use it, you have to put it in double quotes, backslash b, double quotes. And then first one is m, second one is n. Let's say you do that. I mean, normally we have no reason to do this, but just to illustrate this, I'm using this example. What does this mean? It says write the value of m. So on the screen, the value of m will come up as 6. And after writing 6, normally the cursor goes to next line. There's a cursor, it doesn't always show, but there is something to indicate where the next item will be written. So if you don't have this backslash b, then the n will be written at the cursor, where the cursor is, which is next to this. So it'll appear as 6, 7 if you didn't have the backslash b. But with the backslash b, you're writing 6, and then when the cursor is next to the cursor is now next to the 6, you're moving it back. So cursor goes to in front of 6, and now you're writing 7. Basically, that means you're writing 7 on top of 6. That's what you will get. You don't normally want that, right? So you don't normally do that, but I'm illustrating the use of b, the backslash b. So if you want to go backwards several spaces, you could write cout double quotes backslash b, any number of them. So this will make the cursor go backwards 3 times. Students in this course didn't find any use of that, but it's there. Backslash n. So if you use backslash n in double quotes, that is exactly same as writing ENDL. It goes to new line. T means go to tab position. On the screen, we don't normally see any tabs, but on the screen there are some hidden tabs. So there's a tab here. If this is the screen, there are tabs hidden. So when the T is executed, normally the cursor is here, the writing on the screen, wherever you're writing. When your tab is executed, it goes to first tab. If you have another tab, that'll make it go to the next tab. So the tab will make the cursor move to the next tab position. If you want to write a backslash as part of output, you have to write 2 backslashes because backslash has a special meaning. If you want to write a single quotes, you have to write backslash quotes because single quote by itself has special meaning in C++. Now these hardly ever you have to use. Backslash B also almost never used. But backslash A, backslash N, backslash T are useful. So we're going to see some examples now about how to use them. So here is example, int x equal to 53. I don't know what this is. And after that, cout backslash T, and then value of x is backslash N, backslash T. See that all of that in double quotes. So whenever you want text as part of the output, you need to put that in double quote. In addition to the text, any escape sequence you want to throw in, you can throw in within that same double quote. That's what I just did. So this means it says, go to the first tab position, write this text, then go to new line, and then tab over on the new line, and then write X. So on the screen, here's how it happens. The cursor would be at the front of the screen, at the very beginning of the screen, right here, where I have put the cursor. So yeah, this is where the cursor will be on the screen. Because of the tab, backslash T, it goes to the tab position right here. There it writes the value of X is, and then because of the new line, it goes to next line, and then it tabs over on the next line. That's how it comes here and writes the number 53. So the output will come up this way because of your escape sequences. Okay, so here's another example. I'm writing, please press the enter key, but I'm doing it after all these escape sequences. So can somebody tell me what exactly will happen when this is executed? Anybody?
It starts a new line.
Say again?
Starts a new line.
Before the new line, there is something else.
It starts.
It makes the beep sound.
It makes a beep sound,
Starts with a beep sound, and then
it starts a new line,
and
then a tab
over, and then it will write this text, right? And then the cursor will go to new line and wait there. Okay, all that is done right there. So if there is another cout statement, that will be writing on a new line because of this backslash n here. It moved to the new line. So all that will be, so you can combine all these escape sequences to produce the output exactly the way you like. The more control of the output we'll learn much later in the course, near the end of the course.
I have a question. I forgot. So the semicolon, is it used after every phrase of each code?
Every C++ statement, the complete statement will end with the semicolon. Yes.
Okay. Thank you.
Right here, index equal to 53, that's one statement. Cout all this is another statement. So semicolon has to be there at the end of every statement.
All right.
If you miss the semicolon, the compiler will not compile your program.
Oh, okay.
All right, going on to the next page. Here is another example. Int val1 equal to 25, val2 equal to 36, semicolon. See, that whole thing is one statement. So then it's a semicolon. Now C out val 1, and then double quote backslash n, and then val 2. That means write the val 1, go to new line, write val 2. So 25 and 36 will appear on 2 separate lines. So this, it does exact same thing as ENDR, identical. Okay, no difference. Okay, so going on. So that finishes the escape sequences, preprocessor directives. There is what is called preprocessor. Before the computer processor processes your program, there is a preprocessor, which is part of the processor that will be processing your preprocessor directives. The preprocessor directives would be statements that begin with pound symbol. These statements tell the system or tell the preprocessor to do something before the program is processed, And one of the things we normally have to say is asking the system to include the libraries that we need to use. Very often, there are libraries of programs that we can access and use, and there are some libraries that are needed always. And IO stream is one of those libraries. So the IO stands for input-output stream. So input-output stream, that's what it means. So this is where all the input-output related programs are there. We learned about cout statement, which will write the results on the screen. So the cout, how does it understand cout? When it sees cout, it will go to the corresponding program in the IO stream. There's a program corresponding to a cout that tells the system exactly what cout means, exactly how to carry that out. And that's all in that library file, IO stream. So cout will be understood only if the IO stream library is included. Similarly, cin, which we'll be learning much later in the course, that statement will be understood only if IO stream is included. So this is where all the input-output related files are there. Input-output related programs are there. So if you include this, then the system will automatically find them. So you need to throw this statement at the top. This is a preprocessor directive that tells the system to include the library called IO stream. So you put that in, pound include IO stream at the top of the program. Only then the cout cin will be understood. When you're compiling your program, if the compiler says, I don't understand the cout, that means you didn't include IO stream. That's what it means. Okay, that's the indication that you need to understand what the compiler says. So if the compiler is having trouble understanding cout, that means something wrong with your pound include IO stream. So you have to go back to that and fix it. Okay, so the complete program will have to have this pound include IO stream at the top. There is also another statement you need to write. So let me write that here. Before the main, somewhere before the main, you had to write using namespace std. That indicates that we are using new standard. This is something, after 2005, we have to use in any program because there is new standard for C++, and you need to say, I'm using new standard. And that's what this statement says. And you have to use these words exactly as the way I have written. Using, and then space, namespace, and then space, std, semicolon. That needs to go there before the main. After that, the main statement tells the system that this is where the main program begins. Why main program? Why do we have to declare a main program? Because later you will be learning that a program can have many parts, not necessarily one program. A program may contain many programs put together. And so you need to declare a part of that whole thing as your main program. And so that's what we're saying here by stating main. After the word main, you need an empty parentheses. You will understand later why we need that. And then a curly bracket. I recommend putting the curly bracket on a new line. Sometimes people write them here, very next to main. But if you write it on a new line, it'll be very clear where the main program begins. You write the body of the main program here, and then end it with a closing bracket. So main program should begin with an open bracket and close with a closed bracket. In between, you have C++ statements, which will be the body. At the top, before the main, you need found include IO stream, name, using namespace std. All that is necessary. Okay, so let's understand comment. Sometimes within computer program, we have to write comments in English. Why? Because in the programs we write, we have to always presume that the program will be read by other human readers, basically other programmers. In the programmer's world, all programmers have to work together because it is important that you use programs that are available that you can use within your program, and others, you should expect others to use your program as well. So you should make sure your program can be understood by other human readers so that they can figure out whether they can use it or not. So for that reason, we write English explanation within the program sometimes. Also at the top of the program, we put some English paragraph explaining what the program is good for. That way, anybody considering using this program can understand what this program does, without having to read the whole program. So as a beginning programmer, you're supposed to practice all these things in your program, and that's why it is required that you do this. You write a comment at the top explaining what your program does, and also write a comment which will tell them who the author is, who you are. So how do we write these? When we write these English comments, we want to make sure that compiler will ignore them, because compiler is going to translate our program, and this English sentence is not part of the program. So we need to tell the system that this is for human reader, ignore it. So we will be doing that by putting // in front of that sentence. Anything that begins with / will be ignored by the compiler. It'll be assumed to be for human reader. So / is one way. You can write many lines of comment, all of them begin with /. Or at the end of a statement, you want to add a comment behind a statement. You can do that. Just begin with a /. System will ignore, the compiler will ignore anything that begins with /. Also, another way to write comment is if there are more than one line of comment you need to write, then you begin with the /* and then write any number of lines and then end it with //, and that whole paragraph will be ignored by the compiler, and it will be only for human reader. So we're going to see some examples now. So here is a complete program. The exercise says, write complete program to compute the average of 3 numbers. So program begins with you include IO stream on one line, no semicolon there. Notice that statement will be it has to be on one line and no semicolon necessary. You cannot break that into several lines. Using namespace std, ends with semicolon. Then I'm writing a comment right behind this line, behind this statement. I'm saying this is necessary in every program, which is true. And then I wanted to write another comment that explains what this program does. And notice that that begins with /* and ends with //. If I want to write my name in there, which you are supposed to do, then that would be also beginning with 2/ and write your name there. So in your programming projects, it is required that you write this comment block that explains what the program does. And then this line, another separate comment, which tells you who you are. Then the main program begins, and curly bracket is the beginning. And now declare the variables, find the average. You just add up the numbers and divide by 3. Now notice that you need parentheses to say divide the whole thing by 3. And hold on, I did something. All right. So you need parentheses to say add up first and then divide the whole thing by 3. C out average is equal to, if I put that in, then this text will appear in front of the answer, and then average. ENDL, so that I have an ENDL at the end, so that everything afterwards will be written on the new line.
Professor,
Professor,
can you like repeat what the arrows are for again? I forgot.
This arrow, you mean?
Yeah. I forgot what they're called
Yes.
too.
After the C out, you have to have the 2 inequality symbols, which we read as arrow,
Okay.
before writing anything. Okay.
Okay.
And-
What? And it repeats though. So
Yeah, repeats. In other words, only one item per arrow. So after one arrow, one item. This whole text is one item. And then there's another arrow, another item, the variable.
okay.
Another arrow, another item. Each item has to be separated by this arrow.
Okay.
hey, Professor.
Yeah.
Can you explain line number 2 again and what that does, why we need it?
This line?
No, the using namespace STD.
Oh, yeah. This line basically tells the system, tells the compiler that I'm using new standard of C++. Okay. Before 2005, there was older standard, and after introducing new standard, you're allowed to use old standard or new standard. So it's kind of a little complicated situation. So we want to use new standard, so you need to say this at the top. All right, it's just
Okay, thank you.
to call it a formality.
And that's gonna be all our code, or most of our code, right?
Yes, you need these 2 lines in all your programs. Okay. Every program must have that. If you don't include either one of these, it'll complain right here. C out. Compiler will say, I don't understand C out. Okay. Because the C out is explained in pound include IO stream, and pound include IO stream is a new version of library, and so only if you put this in, it'll recognize that you are using new version of the C++, and this is the library. All that. So basically, these 2 lines together will be in every program you write. All right. Any other question about that? Okay. So before the main program, you have to have those 2 lines, and normally you write our comments also before the main. You can write comments inside the main too. Yeah. Question? All right. So that's how you write the complete program. So that finishes section 2.2. So at this point, I want to go to the Windows program and show you how to use the compiler. And I'll be coming back to this to start 2.3. But I want to do the program first, running a program before coming back to this. So I'm going to stop sharing this window. 1 second. Where is my, yeah, okay. All right, I'll leave that there. I'll stop sharing and go here. Okay, 1 second. I have to allow screen sharing. Okay. All right, so okay, so I'm going to just copy this whole thing. Okay, those were things I did with the previous class. So let's see how to run the program. Now, if you have the program already installed, then you just open the main menu and you will see the bloodshed right there. So go there, and inside the folder, you have the .c++ program. Click at it to run it. And when it runs, it has its own editor. So you see the editor right there. That's your editor. To create your program or project, every programming project is going to be a project. Inside the project, which is inside the project folder, you're allowed to have many files. So you had to provide a name for the project folder and then name for every file you create. So first I have to say file, new, project. So start a project, and then it'll ask you what kind of project are you doing. Windows application means application with menus and icons and all that. That's advanced programming. Now, if you are computer science major, you may want to consider taking CSCI273, which is advanced Windows programming with the menus and windows and all that. That I teach. That will be the third course, 273, CSCI 273. It starts every other spring because not all the students sign up, so it's not offered every semester. You may want to consider joining that if you, after you take 272, only then you'll be ready for 273. Okay, so Windows application is not our focus. Console application is the one. Console application means, you run your program, the output will come up on a console window. Not the way we like, the modern way is, with the menus and windows and everything, your output should show right there on the window you're working with. That's how it will be in a Windows application. But we're not ready for that. So we're going to do console application. So a black window will pop up and show the result in this kind of application. So that's what we need to do. That's what we are going to be ready for. So click at that and say, okay. Then it'll bring up a name for the folder. So the folder, the project. I'm going to create a name. Project 2 is going to be my folder name, and save. So I have created project folder. Now this is a file I'm going to type. The program is a file that I'm beginning to type. As you can see, this software, .c++ gives you the things that you normally have to type. One thing it doesn't give you that you have to type is using namespace std. So you're going to have to insert that. All lowercase though. The C++ is case sensitive. You must use only lowercase. You need a semicolon at the end of using namespace std. And it tells you right there an instruction, and I'll explain that in a minute. And you want to write your own comment here. So write your name there. And then you want to say this, you have to begin with 2 slashes or /star. This program finds product of 2 numbers, whatever you want to say, and close with // That will be recognized as comment. Now, int main is, you need that main statement. The int in front of it is not required, not necessary, but you can leave it the way it is. And this thing inside the parentheses is also not necessary, but no harm keeping it, so leave it there. And then this, as you can see, the curly bracket is also inserted for you. I would move it to the next line and then begin my program. Right there, that's where my program begins. So I write all my statements, but I already typed those, so I'm going to paste it here. Nope, I don't have it copied. So I'm going to write my entire program, which is going to be a program to multiply 2 numbers together. So float x equal to 34 point, I'm just making up the numbers, and y equal to so along with these 2 numbers, I need another variable to store the answer. So I'll call it prod, to mean product, semicolon. And then you write prod equal to x times y. As you can see, I'm inserting blank space after the prod, before equal sign, after the equal sign. These are all easy reading, not required. So the spaces are not required. In some places, the spaces are required. Begin like this. Float and x have to be separated by a space. At least 1 space is required there, but you can have more. So prod equal to x times y, semicolon. And then I need to write cout, the output. I want to put some text in front of it. So as soon as I type once double quote, it gives me the ending double quote right there. And I can say product equal to. If I want to go to new line before writing this, I can say \n right there. If I want to go down 2 lines, another \n. And then you write the variable prod space. And again, these spaces are not required. Whenever the spaces are required, I'll tell you. The using namespace std, those spaces are required. And between the declaration and the variable, you need space. Other than those, all other spaces are optional. Prod equal, after writing the prod, I want to go to new line, so endl. Instead of endl, I can always write \n in double quotes. Okay, so this will, that'll be the end of the program. The return 0 is supposed to go at the end of the program, at the bottom of the program. You will understand later why it's there, but even if you miss it, no harm done. In the new version, you can miss the return 0. Here, I need to write one more statement. System. That's a requirement for this particular compiler. similar to this, some other compilers also require this, and I'm going to write this and then explain why. System pass in double quotes and semicolon at the end. Okay, so the reason for that is if I don't throw that in, the answer, the window, the console window in which the answer shows up, it'll pop up, show you the answer, and then disappear. That's how the compiler does. This particular one, and there are many others, do the same. So we want that window to stay until we are ready to get rid of it. So that's what this statement does. It'll pause that console window. And up here, this comment from the compiler, that tells you the same thing. You need to either use get.ch or system pause to keep the console open. So that's what I'm doing. So system pause. So this comment is just to tell you, it tells you that you need to do this. I can get rid of that. Okay, so my program is now ready, and I'm going to compile it. So first thing you need to do is save. Remember, everything you typed so far is only in the memory. What you're typing is only going into the memory. So only when you select save command, a copy of this memory version of the file is saved on the hard disk. A hard copy is saved. The compiler, unfortunately, can only work with the hard copy saved. It cannot work with the memory copy. So you have to save it before you can compile. So I only have a name. No, I don't have a name for this file. I have a name for the project folder. I don't have a name for this file. So when I select file, save, it's going to ask for a name. So I'm going to name it as main6, just because I already have some other mains. So main6, save. So that's the name for this file within the project folder. So now it's saved. So I can ask the compiler to compile it. Here's how you compile. You go to the execute menu, and you see the file compile. Menu compile, menu item. There's another menu item, compile and run. That will be for compiling and running. That you would choose that only if you're confident that your file will compile without any errors. But you shouldn't be confident when you're a beginning programmer. So you should compile first. So when I select compile, you see things are going on, and it says there's an error. See there at the bottom of the screen, right there. You should always pay attention to the first error message. Don't worry about the other ones, because one error leads to many other errors. So fix the first error and then compile. And if you get another error, fix that. Don't worry about the other errors. So it says error, ST is not a namespace name. That's because I mistyped ST. I don't know when I erased. I think when I erased that comment, I erased part of the statement. So I need to put the D back in and the semicolon. Let me make another error. I missed this. I'm going to miss this semicolon behind that statement. Save this. And then each time you make a change in the program, you have to save the program before compiling. Many students miss that. They keep compiling without saving, and the same error pops up. Same message pops up because it's compiling the original version that you already have it in the hard disk, not the one you have corrected. So the corrected version is not being compiled. So it's a very common error. The students come up and complain that the compiler keeps giving the same error even after they corrected it. That's because they didn't save it. So you made a change and you need to save it. Oops, apparently I have saved it. So, because that's why the save command is not available. You don't want to select save as, then you'll be giving another name. You don't need that. Okay, so I'm going to say execute, compile. Okay, see that it highlights where the problem is. The problem is actually the previous line, but because you missed a semicolon, it has combined both lines into one statement. Now it recognizes the prod equal to x times y and the cout all as one statement. So it tells me the error message here that yeah, you cannot even yeah, right here, second line. Second line tells you that expected semicolon before cout. See, read that message, expected semicolon before cout. So before this cout statement, a semicolon is expected. So this error was correctly pinpointed, but it doesn't always perfectly, it cannot always perfectly pinpoint it, but at least it will highlight the line. So you can focus on that line or the previous line to figure out what the error is. Sometimes the error is in the previous line. So here, the error is in the previous line, but it highlights this line. Okay, put the semicolon back in, and then select save, compile again. Okay, now it says errors 0 at the bottom. See that, error 0, warning 0, error 0. And that means it compiled correctly, no problems. So that means machine code has been produced already, and it is in a separate file. And that file is in the same place where you saved this project. That machine version is already saved. It wouldn't show you that because it's not going to make any sense to you. But if you select run, it'll run that file. So execute, run. That will run the compiled file. And there is my result. See, because I have the \n, it skipped the first 2 lines of the output, and then it wrote the new output. And after the output, it writes this text, please press any key to continue. That's because of our system pause. Our system pause is making it do that. Only when I press the continue button, it'll go to the new next thing. So press that, and now it completed everything. If you press the enter key again, the screen will disappear. So this output right here is exactly what we need to print, but unfortunately, there is no print command that can print this. There is print command that can print the original file. I'll show you in a minute, but there is no print command to print this. So to produce a output to produce a document that you can upload as your project, you're going to have to show the following. You move this out of the way and shrink it. You go to the corner, you'll be able to shrink it to a small one, because all these black spaces are going to correspond to using black ink from your printer if you're printing it. You don't want that black, too much of that. So reduce it as much as you can, and then move the entire window down to go below the project. So now the program is showing and the output is showing together, right? Now there's no way of printing this. The only thing we can do is we can get a screenshot. So in the Windows, the screenshot you can get by pressing the key that says PRTSC. It's at the top of the keyboard. If you look at your keyboard at the top, there are F keys in that line. After all the F keys, you will find PRTSC. Press that just once. Just once, that's all you need. A screenshot has been taken. A picture of the entire screen has been taken. And now I need to process that. I don't want to have all of these distracting things. I want to be able to produce a document that shows exactly the program and the output together. So I can shrink this, or whatever I want to do with that. Close that. And I'm going to go to another software, try to shrink.
Professor, is this all the same for the Mac that you, and like the application you told us to download?
In the Mac, you had to use Xcode. No other software is available for Mac, but Xcode is good enough. It has everything you need.
Is it the same thing that you just did here, like how to like run it and
Yeah.
stuff?
is very similar. It'll produce output on a black screen, and you're going to have to take screenshot the same way. But in the Mac, I'll show you in a minute how to do this screenshot.
Okay.
All right. So here I have the screenshot. So I'm going to go to the, I'm going to use the Paint. You can use any software, but Paint is easy software to use for editing pictures. What I have is a picture. Screenshot is a picture. So I'm going to create a new file in the Paint is called 3D Paint now in the new version of the Windows. So here is the Paint. I'm going to paste it just by, you can select paste from here, or Control V is always paste. Paste from the menu, and that'll paste the entire picture, the window shot we took, screenshot we took. All right, so now I need to eliminate the unwanted parts. So you click at the crop button, then the selection changes to crop selection, and move this over to select exactly what you want to have, and then click at select. Then it will crop out everything else. So what you need is right there. So I'm going to, since the select button is already selected, I can select by using mouse any portion of that, and right click and copy it. Now, if you are going to, if your project involves only one page like this, then you can upload this file itself. I can enlarge this. I can enlarge it. Okay, so this file itself is good for uploading. It's a JPG file, but any format can be uploaded into the assignment system, Turnitin system. So this can be uploaded, but in some projects, you have to combine more than one document, more than one page. So I'm going to show you how to do that. I just copied this a minute ago. I'll show you again how to copy. You can select, make sure this select button is, this is selected. Then you can click at any part, any portion, and select what you want to copy. Right click inside and copy it. Now you have a copy of it, and shrink this and go to Word. I'm going to use Word. Word is the best for producing a document that has several pages. So Microsoft Office Word. Okay. So I just press Control V, or select from the menu, you can select paste. That'll paste it. So I have the picture pasted. So here the advantage is you can paste any number of things. So the cursor is down here. I move the cursor further down, and I want to paste another picture here. So go back to the dev C++. And in your first project, it tells you to do this. It tells you to modify your program and make another output. So that's why I'm showing you that. I'm going back to the program. I'm changing the data, and then I'm going to save it. I'm going to eliminate these backslash ends. Okay, so save this file. So I modified the program. This is part of your first project. You need to modify the program, run it again, and then produce another screenshot. So execute, compile. All right, it compiled fine. So I can go ahead and run it. And there's my new output. It's a new number. And I'm going to have to swing this one. Okay, move it down. And I need to take a screenshot now. So print screen, press print screen once. And now you need to go to the Paint 3D and just paste it. It'll eliminate, the Paint 3D doesn't allow more than one document to be pasted. So if I now paste the other one, it'll eliminate this. So the previous one is gone. So now, oops, no, it is not. All right, I will just create a new. Don't save. No, I still have the original picture. So apparently the print screen didn't work. So I'll do that. Saying this, and I need to take a print shot again, print screen. Okay, have a print screen. No, that's still the same original one. When I click outside, the black window disappears because it goes behind, basically, that's why. Okay, I'm going to take another print shot, print screen. The print screen is not working properly. Something is going wrong with that. But let's try again. Paste. No, it's still pasting the other one. So I'm just going to work with this. This Windows computer is very old and the keyboard is very weak. I think the print screen button is not working properly. But I can go and just show you how to work with the Word file and paste another picture. So my cursor, I'm on the Word file now. The cursor is at the bottom. Make sure the cursor is not at the top. We want the new one at the bottom. So Control V will paste the new one. Something went wrong with that pasting. Okay. Yeah, I have the other picture at the bottom, but it seems to have double picture. Oh, that's the split screen. That's what the print screen actually has the picture. Let's try to paste it again on the. So the print screen actually worked. Anyway, it doesn't matter. You know how to edit it. So I don't want to waste any more time on this. But as you can see, I have the first picture at the top, second picture at the bottom. The second picture, if you want to shrink, you can swing it. On the Word, you can do anything after you paste. So you can shrink if you like, but don't shrink too much. It has to be readable. So now the two outputs are on one window document. And you can save this Windows file and upload that. So file, save as. And then you can save it as any file and then upload that file. It has the two pages, both pages. So some of your projects require both pages, some require only one page. If it is only one page, then the Paint document is good enough. If it is going to be more than one page, you may have to use Word. All right, I'm going to stop sharing here unless you have a question. Anybody, any question on this?
Can you show them for the Mac?
Yes, I will. So let me stop sharing here. And I'm going to share the Mac screen now. Okay, we're back. And so let's see, let's say in the Mac, it's a little bit more convenient. You don't have to bring in the Paint software to edit because Mac allows you to take a screenshot of a portion of the screen, not entire screen. Windows, in the Windows, you press the print screen button, it takes a shot of the entire window. It doesn't give you an option of portion. So here it gives you a portion. So you run the Xcode and run the program on Xcode. The output will be a black window just like that, just like the other. No, it won't. It's a little bit different. But anyway, you can take a screenshot of whatever you like in the following way. Command Shift 4. Those are the three buttons you have to press at the same time to get a screenshot. So I'm doing that. I'm going to show you how to do that. I'm pressing Command Shift 4. And now you can see the cursor has turned into a cross symbol. That allows me to select the area that I want to take a screenshot of. So I'm going to select the portion I want to copy. This is what I want to take a screenshot of. As soon as I release, I have the screenshot right here. This is my screenshot. Now, if you can just close that, it'll be there as a document, as a JPG file, and you can upload that. So there's no editing needed here because you can take the screenshot of exactly what you need. So no need for editing. You can also paste these pictures to Word file to have more than one page on one document. So the Turnitin system allows you to upload only one file. You cannot upload more than one file. So any number of documents you need to upload, you have to combine them into one file. Word can do that. Word can combine text and pictures, anything, into one file. So use the Word or any other software you have. And my understanding is students and faculty of CUNY have access to Microsoft Office. If I'm right, then if you log into the CUNY portal, everybody has access to CUNY portal. CUNY portal has a store, a software store, and you go there and you find what you need and download. I am allowed to download. My understanding is students can also do that. I may be wrong, I'm not sure, but try that. Then you have software that you can use as long as you're a CUNY student.
Professor, I'm on Xcode and it's asking like for our template, it's asking for either app, document app, game, or Swift package. I'm not sure which one I would choose.
You don't need any Swift package. It's all there. You're not understanding it maybe. Now follow the document I have posted on the supplements, course supplements. There's a document that explains to you how to use Xcode. Try to use that, and if you still need help, you can join me during office hours. I cannot spend the class time on two different softwares, okay? So
Okay.
try to use that, and if you still need help, join my office hours. All right, I'm proceeding to the next section, 2.3. So here you're going to understand data type conversions. By the way, you have a project 2.2.2, that's due Monday. And I have already posted the link on Turnitin system to upload your project. This project is very easy, very elementary program. You write the program. There are two parts. I showed you how to combine the two outputs into one document and upload it before Monday. You also have a homework, which is going to have some problems on 2.2 and some problems on 2.3. The exact problem that you need to turn in will be clearly identified in the link, in the Turnitin link. So don't rely on the course calendar too much. You need to, for the problems to turn in, you need to focus on that link. You may have to click at that someplace on that link to find out what should be turned in. It'll tell you exactly what problems to turn in for the assignment. Last time, some students missed the 2.1 problem, section 2.1 problems, because they didn't follow the instructions on the link. Instead, they followed the course guidelines. So I want you to follow that link in the future. I will not allow a late assignment turning in the future. So please do it on time, do all the problems. So data type conversions. Your data will be converted to a different type depending on the situation. And there are different situations in which conversions will happen. And I'm going to teach you all that in this section. So first, integer to float type conversion. That will happen if you remember in the last section, I said, if you declare a variable as float type, then you can only store float type value there. And if you declare it as integer, you can only store integer. What if you assign a value that is not matching the data type of the variable? That's when the conversion happens. That's one of the places where the conversion happens. So here's an example. I declare val as float type and then assign 23 to it. Now 23 is integer. Why? Because it doesn't have a decimal point. Remember, a data itself has a data type, and system will identify it by looking at the data. This data doesn't have a decimal point, so it is integer, and I'm assigning it to float type variable. So it'll convert that integer to float. So when it converts integer to float, only thing happens is the decimal point. Just a decimal point is added to it. So what you have stored in the memory is 23 point, not 23. Does it make a difference? Yes, it makes a lot of difference. In computer programming, the decimal point matters. In math, I know that if the number is whole number, whether you have decimal point behind it or not, doesn't matter. But in computer science, it matters. Sometimes it makes the difference between getting correct answer and wrong answer. As we proceed, you will understand that. So this decimal point is important, and you need to understand that it'll be added when you are storing a integer number in a float type variable. So if you're doing the other way, if you declare an integer variable size and assign 23.8, it knows 23.8 is float type, but you're assigning to integer type variable, so it's going to convert it. 23.8 converted to integer will be 23. Basically, the 0.8 will be dropped. So converting a floating point number to integer means dropping the fractional part. It's not going to round it for you. It's going to drop the fractional part altogether. And so when you assign 23.8, it's going to drop the 0.8, and you have 23 stored in the memory. That's all you have. Okay, so here's an example, another example. Tip is declared as integer and tip equal to 4.86. You're going to have only 4 stored in there. Now, these conversions are sometimes useful. So here is an example. The example 2 illustrates how I can use it to eliminate the integer part in my number. So the full value variable, full value has 32.64. If I want to replace that value with 0.64, eliminating the 32, I can do it in the following way. Declare another variable whole num and copy full value in it. Now the whole num has only 32, integer part. After that, from the full value 32.64, subtract the 32. Now you have 0.64 going back into full value. So full value now has 0.64. And this is, sometimes this is what we need to do in some problem, in some computer programming. So here's an example problem, a problem similar to homework problems you have. write statements to replace value of val, the variable val, with fractional part. That means variable val already has some value, but we don't know what it is. In this example on the slide, I have 32.64, but in this question here, which is similar to one of your homework problems, and there are several homework problems that are going to be similar to this. Val already has a value, we don't know what it is, and we need to replace it with the fractional part. So the statement you're going to write will replace it with fractional part. So let's say val already has, I'm making up a number here just to illustrate. So let's say it has 12.64. So after your statements are executed, 12.64 should be replaced with 0.64 in this memory val. So here's how we do it. We don't know what is in val, but I'm going to have to create another int type variable, int n equal to val. In this n, I have integer part of the original number. This example has 12.64. See, a question like this sometimes will give you an example to illustrate or explain exactly what needs to be done. That is only an example. This 12.64 is example. Don't use that number. We don't know what value is actually there in the variable val. So your statements have to work no matter what value is there. So if the number is 12.64, then n has 12 now. So now to get the fractional part, what I do is from val, I subtract n from the original value of val, which is 12.64 in this case, subtract the n, that will be the fractional part. If I assign that to another variable, say num, then I'm storing the fractional part of the original value of val in another memory. Num is another memory, and putting 0.64 here is not achieving the task. What is the task? The task is to replace the value of variable val with 0.64. Placing the val 0.64 in another memory cell num is not going to do it. Val still has the original value. So that's not the way to do it. Instead of num, what do I have to do? Anybody?
Don't you put val into?
It should be val, right? Val equal to val minus n. I know this is mathematically incorrect, but this is not math equation. This is assignment. So this says whatever val has, subtract the n from it, put the result back in val. So that means the value of val is erased and replaced with 0.64. That's how you achieve the task. Okay, I'm explaining this because very commonly students do this wrong.